Good morning, students. I am Dr.R.Suganya, Assistant Professor, Department of Computer Science with Cybersecurity. Today we are going to see about the OS security. The overview of operating system functions. So we have the users. The user will be interacting with some applications through operating system. So like synchronization, concurrency, control, deadlock, management, communication, accounting, these are all some services in operating systems. So there will be some resource allocations in operating system like data. For data there will be some resource allocation. It will be stored in operating system, and program libraries, CPU, memory, input output devices. So these are the overview of the functions. Outline: access control concepts, matrix, ACL, capabilities, OS mechanisms, amoeba, distributed capabilities, Unix file system, set UID, Windows file system, EFS, guidelines for designing secure OS. So we have some access control like common conception that the system knows who the user is. User has entered a name and passwords or other info. Access request passed through gatekeeper. OS must be designed, monitor, cannot be bypassed. Decide whether the user can apply operations to resources. There are some user 1 to user m, and user they can access files like file 1 to file n. That the files can be, that is to read that file or write the file, or access control read matrix. This is a Lampson matrix. It is whether we can read or write files. So here we can say access control list, that is ACL is access control list. Store column of matrix with the resources. Capability: the user holds an unforgettable ticket for each user. Capability list: the OS holds a ticket inaccessible to users, cryptographically protected capability. When a process executes, it operates. It is there will be a process, it can access, the process can be the files, and it can the device of process and the data storage. When process calls sub procedure, domain for main, it is a domain, and the OS creates the process, files and devices, and the sub process which takes place to store the data. So access control list, that is associate the list with each object. Check user or group against list, relies on authentication which needs to know the user. Capabilities: capability is unforgettable ticket associated with object. It can be passed from one process to another. Reference monitor checks ticket, does not need to know identify of user or process. Delegation: process can pass capability at runtime. Revocation: remove user or group from list, try to get capability back from processes. Possible in some system if appropriate bookkeeping. OS knows what data is capability. If capability is used for multiple resources, it have to revoke all or none. Here we have the server port, object, writes and check field. Distributed operation system. Multiple processors connected by network. Process on A can start a new process on B. Capability based system. Object, abstract data type on which certain operations can be performed. Example: files, processors, disk blocks. Capability: a handle on the object. Invoke operations through message to server. Send messages with capability and parameters. Server uses object hash to identify the object. Server checks writes field to see if operation is allowed. Check fields prevents process from forking capabilities. So we have the owner capability. When server creates object, it returns owner capability. All write bits are set to 1. Check field contains 48-bit random number stored by the server. Derived capability: the owner can set some writes bits to 0. Calculate new check field. XR writes fields with random number from check field. Apply one-way function to calculate the new check field. Server can verify writes and check file. Without owner capability, it cannot force derived capability. Owner and group. Permission set by owner is read, write and execute. Owner group, other represented by vector of 4 octal values. Only owner the root can change permissions. This privilege cannot be delegated or shared. It's set user ID bits discussed in a few slides. Owner can have a few privileges than other. It's prioritized resolution of differences. The question is, if user equal to owner, then owner permission, else if user in group, then group permission is other permission. Each process has 3 IDs plus more under Linux. Real user ID, same as a user ID of parent. It is used to determine which user started the process. Effective user ID, from set user ID bit on the file being executed or system calls. It determines the permissions for process, file access and port binding. It saved user ID, so previous ID can be restored. Real group ID, effective group ID used similarly. Root, user ID equal to 0 for super user root can access any file. Fork and executive inherit 3 IDs except exec of file with set user ID bit on. Many sensitive programs owned by root has a set UID bit on. Horrifying, whether like ID that is root user ID which is unchanged and set user ID which is copied from executable user ID. So we have owner sets its O with CH mode, that is U means owner, G is group, O is all other user. So CH mode go plus X executable file. Set the user ID, that is bit, and it is with read write executable mode and read write executable file. So here we have the set user ID and set group ID is given, which is G is a group ID and U is a set user ID. So here we have a super user which has unprivileged user and set UID executable UID. So here we can have example the RUID which is the relocatable owner ID, that is which has set user ID program which has been executable, and get URID and set UID. So here the owner is just executing accessing the particular resources which is executable file.